Alright, so now we're going to talk about the properties of matrices. Alright, so a few notes. Typically we're going to use uppercase letters to denote matrices. So we're going to say this is matrix A, for example. So we'd say, alright, A equals this, or whatever. Okay. Alright, now matrices have a classification. They're classified by their dimension or order. Those words will be interchangeable. So the dimension or the order of a matrix is the number of rows by the number of columns, the m by n thing. So right up here, this first one, matrix A, its dimension would be a 2 by 2. Because you have 2 rows and 2 columns. Whereas this one over here would be a 2 by 3. 2 rows and 3 columns. And remember, it's always rows by columns. All right, so this one down here would be a 3 by 1. Everybody see that? You only have one column. This is actually referred to as a column matrix. When you just have one column there, it's referred to as a column matrix, which means, brilliantly enough, this one over here that's a 1 by 4 is called a row matrix because you just have one row. So just in case you run into those words, column matrix and row matrix. All right, so the dimension of a matrix, just the rows by columns. All right, another note. 2 matrices are equal if they have the same dimension and their corresponding elements are equal. So here are 2 matrices. This one's a 2 by 2, and this one's a 2 by 2. Right? So if they're going to be equal, well, they have the same dimensions, so they could be. So if A does equal B, then what has to be true? Right? Well, then A has to equal -3, right? Because the corresponding entries have to equal. This row 1, column 1 has to equal row 1, column over here. X has to equal 0. Y has to equal -1. And 4 has to equal B. Everybody see that? Right? I know it didn't seem like we're doing much right now. Just trying to get the idea across that the only way 2 matrices can be equal is if they have the same dimension and the corresponding entries are equal. Right? Alright, so let's go on to the next one. Alright, in order to add 2 matrices, the 2 matrices must have the same dimension. So you cannot add matrices that have different dimensions. Alright, then to add the 2 matrices, we simply add the corresponding elements of the matrices to get the resultant matrix. So for example, if we've got A here, which is a 2 by 2, and B, which is also a 2 by 2. So we can add these up. And so we could say, if this is A, this is B, find A plus B. I'm going to also encourage you to just start writing it out like whatever A is. There's A plus B. And the reason why I'm encouraging you to do this is because when we do multiplication, it's very important that you write this out. All right, so just getting in the habit now. All right, so then to add these 2 matrices together, just add corresponding entries. You're going to get another 2 by 2 matrix, right? And so 1 plus 3 would give you 4. 2 plus 1 would give you 3. -1 plus 18 would give you 17. And 0 plus -5 would give you -5. And this is the new matrix. That's the sum of these 2 matrices. Make sense? Alright, not too bad. Alright, so then we've got this thing called scalar multiplication. Now, scalar multiplication, everybody know what a scalar is? A scalar is just a real number. That's it. So we're just taking a real number and multiplying it by a matrix. And this is how it's defined. The product of a scalar, a real number k, and a matrix B is this new matrix k times b, where each element of that matrix is k times the corresponding element of your matrix B. So for example, if A is -3, 2, 1, 5, -1, 0, this matrix right here, then to find -2A, we simply do what? We simply multiply every single entry inside A here by that scalar -2. And that gives us 6, -4, -2, -10, 2, and 0. That's it. Scalar multiplication, we just multiply every single entry inside the matrix by that scalar. That's how it's defined to be. Alright? Don't make it any harder than that. Now, because of that, that allows us to now talk about subtraction. Right? If A and B are matrices and they have the same dimension, then we can subtract the 2 matrices. Because remember, you can think of A minus B as A plus a negative B, and you have that -1. that would be a scalar multiplied times b, and so you could run that through. Everybody see what I'm talking about? So if you've got two matrices, say 3, -1, 2, 4, and we're subtracting another one, 5, 7, -8, and and -2, right? So one thing you could do is change this to a plus and -1, and then multiply everything inside by -1, and then just add them up, right? Or you can just subtract right away. 3 minus 5 would be a -2. You just have to be careful of the signs. -1 minus 7 would be a -8. 2 minus a -8 is a 2 plus 8, and so that would give you a 10. And then 4 minus -2 is 4 plus 2, which would give you a 6. All right? So it doesn't really matter how you do the subtraction. If you don't change it to addition and then have the scalar multiple of -1 times b, then just be careful when you do the subtraction. Just be careful of your signs. All right, so right now we've talked about adding matrices, not too bad. Subtracting matrices, not too bad. And scalar multiplication, again, not too bad. All right, so one thing I'm going to leave you with in this video is what's called it's called a zero matrix. The zero matrix just means that all the elements inside the matrix are, what do you think, what number? That's right, they're all 0. So every entry inside the matrix is 0. So literally, we have a zero matrix for every single dimension. Follow me? All right, I know that doesn't seem real exciting, but just like we've got the number 0 for real numbers, where you take a number and its opposite and add them together, you get the number 0. The same thing happens with matrices. If you take a matrix and subtract itself or add its opposite together, you're going to get a zero matrix, and that means every entry inside the matrix there would be 0. So these things exist. I'm just making you aware of them. All right, so those are the first few properties of matrices. We've talked about adding, subtracting matrices, and don't forget, in order to do that, they have to have the same dimension. And then scalar multiplication, and that just means take the real number and multiply it times every element inside the matrix. So what we have left to discuss is called matrix multiplication, and that will be on the next video, so make sure you check that one out. Study well, and please let me know if you have any questions.